Welcome to Chapter 3, JavaScript the Big Picture, version 2. I got some feedback and had another look at how I presented this in the last version, and I realized that I got a bit ahead of myself. So we'll go a bit slower this time. We will still not go into the nitty-gritty details, because they aren't really that important. Math calculations, regular expressions, and the truthy and falsiness is rarely encountered. And it's kind of boring, so you should definitely read up on it, but do so in a book or something. Anyways, it's a lot more important to understand how JavaScript operates in a larger scale, because that knowledge is critical to building a professional web application. I often call JavaScript the aha language. You figure out things as you get experience, and there are 3 things that will really affect how you write your code. One of them is everything is an object, the different roles of the function and its scopes, and closures. I will do my best to explain these concepts to you in a practical manner, but we will look at some code as well. As mentioned earlier, JavaScript is a very flexible language. You can do the same things in several ways, and now the browsers are so fast that it isn't really that important how you write your code regarding to execution speed. But it is good to know how JavaScript operates at a low level. The important part of building professional web applications is that you write as clean code as possible. Usually you work in a team, you get new team members, and it might take some time before you visit your code again. It should be easy to understand what it does. Now, this is quite interesting. Writing code is like writing personal post-its. You can write a very complex and effective set of code, but after 3 months, you don't remember what it means. At least not without putting some effort into it. Just like a post-it. We will be looking at JavaScript patterns in a later chapter. I would also like to mention that since JavaScript is more connected to the interface and the end user, the code you write and the result of it is often something more practical than technical. What I mean by that is that the perspective of writing code is different. You're not just moving data around, you're building an interface and a user experience. So, everything in JavaScript is an object. What does that mean? We start off by looking at some of the objects you'll mostly work with. When you write a string in JavaScript, that actually works just like an object. It has properties and default functions, called prototype functions, which we will talk about a bit later. This is also the case for numbers. When you write a function, you don't just write a function. You create an object with its own properties and functions. Arrays are also objects, and of course a custom object is also an object. A custom object is the most basic type of object you can create, but it also has default properties and functions. These custom objects are called singletons. You might be surprised that a DOM element is actually also an object. If you have written basic JavaScript before, you have been working with elements as objects. Whenever you check the parent node, child nodes, and run append child on an element, you work with it as an object, pointing to properties. So everything is connected. All entities originate and operate the same way. And the interesting thing is that you can expand on these object properties and functions whenever you want. So let's have a look. I like to look at objects as tables. They have a property column and a value column. Some rows are default and you are free to add and delete new ones. I mentioned the prototype functions earlier. Prototype functions are functions that are available to you by default when you create a new object. To create a new object, you write it just like this. I have created a variable called testObject and put a new object inside it. If you have knowledge about JSON, you will see that it looks exactly the same. Properties are defined with just text or a string if you want to use special characters. Examples of that here is name and age as just normal text, and then you have increase age, which is a string. The values of these properties can be any kind of object. The really cool thing here is that you can define a property as a string, with white spaces and any other special character. This is where the practical perspective of JavaScript comes in. If you have worked on big projects before, you have probably been told to document by commenting in the code. In JavaScript, that is really not necessary. You can call functions with a full explanation of what it does, just like a comment. I will leave it at that for now. I'll talk more about this in a later chapter. So, how would you access these properties? You can point to the object put into the variable and use dot to point further into the object. You can also use brackets and a string to point to a property. So the property called name and age in this case can be pointed to both by using a dot or by using brackets and a string. The property defined with a string can only be referred to with brackets and a string. To add a property, just point to the object and put something in there. To delete a property, you have to use a delete keyword. The delete keyword is for deleting properties, so you have to point to an object first. In this case, test object, and then the property to delete. You're actually not deleting the value of the property, you're deleting the reference to it. When an object cannot be referenced anymore, it will be cleaned by the garbage collector. You can create objects in several ways, and we'll look more into that later. But the essence you must grasp is that the following code actually is valid. In this example, we have put an array with two names, John and Jack, into a variable named namesArray. Then we add the property logFirst and put a function inside it. The logFirst function creates a variable which contains the first name in the namesArray. This is done by pointing back to the array using the this keyword and pointing to index 0 of the list. Then it logs out what it found on index 0 of the array. The function has become a new property for this specific array, and you can call it whenever you want. You can add properties like this to other objects as well. For example, a function. The important thing to understand is that the array here is first of all an object. It has its table with different properties, and we can add new ones. Now, this is how we define an object. It has been put into a variable called car. It has a model property, and the value of that is Volvo. But that is just one single object. What if you want a bunch of objects which has default properties, values and functions, and you want to be able to change them individually? First, you have to define this new type of object, and that is done with a function. JavaScript kinda does this natively, so all the stuff you work with natively has this kind of definition. What you'll see now is not something you should put in your code, and it's not valid really, but I'll show it anyway to give you an understanding of how things are defined related to something that you already know. So a string in JavaScript works just like an object. It has a value, which is the actual text, the length, and a few functions that lets you manipulate the value. In this case, we look at the trim function. To create a new instance of that object, you use the new keyword. The function returns a brand new string object. So you are free to create a bunch of these string objects and change them individually. We will soon look at a more practical example, but first we have to talk about this thing called functions. So, functions do different things in JavaScript. You could say they can take on different roles. Defining a new object you can later instantiate is one of them. This is what we did now with the string object. We defined how a string should look and behave and used the new keyword to create new instances. The other role is changing, adding or removing properties on the current or other objects. This is your functional code, This is where the action happens. This is a very simple explanation, but keeping in the mindset of everything is an object, this is basically what you do. Now, these functions can be written in different ways and has somewhat different behavior. But don't worry, it's not complicated and you'll mostly only use one of them. But let's look at the first role, defining new object types. So first of all, why would you want to define a new object type? Why not just use a singleton, like we did earlier? Let's have a look. So here we define our new object, person. It's common to use uppercase on the first letter of the function name. You might have noticed the use of the this word in earlier examples. The this word is an important part of understanding functions, and I will point it out as often as I can. The way this works is related to the context. If the role of a function is to define an object type, the this word will point back to the object that is created. So when we use the this word in this example, we point to the object created. In this case, we use the this word to add two new properties, name and age. But what differs this function from any other function? Well, nothing actually. How JavaScript differentiates the functions is how you call them. Here we call the function with the new keyword in front. This tells JavaScript that you're going to create a new object instance. Did you not use the new keyword, it would still execute, but you would not get a new object instance back. So this is important to remember and understand. If we send two arguments when creating the object, they will be put in as values. In this case, John and 18. Again, this is just like a table. And now you see why it was good to define an object type. We also want to create a new person with another name and age. This required a lot less code than if we were to create two custom objects that look exactly the same, like this. But what if we want to do some changes to these properties? We have to define some more functions. You can do this in two different ways. You can add it as a new property, just like name and age, or you can define it as a prototype function. Now, they will do the same thing, but there are a couple of differences. Here we have defined a new property called combine name and age. This property references a function. So whenever you create an object of this type, you will be able to point to the combine name and age property and run that function. As you can see, it points back to the object and its name and age property, combining them with a white space in between. The result here is then return, which we will talk about very soon. So what you should get out of this is that when you create, for example, a new person named John and an age of 18, the function returns that. If we would point to Jack instead, you will get his name and age combined. So this way of doing it will work just fine, but you can actually make it better. One thing to notice here is that every object you instantiate will have a version of this function stored in it and take up memory. This is actually not necessary. Another thing is that you have to define your function within the person definition function, making your code quite large on big object definitions. This is how a prototype version of the function would look. As you can see, the function is outside the person function and can therefore be written anywhere in your code. To create it, you have to first point to the object type, in this case person, then you type prototype and end with the name of the function to call. In this example, it is called combine name and age, as in the previous example. Notice here that even though we are making a general function for all persons, it will understand which context it is in. So the this word will point to John if you run it on John, and Jack if you run it on Jack. Now we have talked about prototype functions to extend your own object types with default functions. But this isn't all to prototypes. you can actually extend other object types also, even native ones. This is a really cool part of JavaScript, and it lets you basically create your own way of writing code. We are now going to extend the default functions of a string object with a new one called noWhitespace. It just removes any whitespace in a text string. You see that we point to the object type of string on the first line there. Then prototype and the name of our extended function, noWhitespace. It just takes the current string and replaces all whitespaces with no space and then returns it. Anywhere in our code we can now call noWhitespace on a string and it will remove the whitespaces from the string. Now think how you can expand on this. I mentioned in the last chapter that jQuery isn't magic. Well, usually when you want to remove a div element from the DOM, it requires quite a bit of code. Let's have a look at how you can remove a div much more easily. This is how you usually would have to remove an element from the DOM. In this case, we find an element by ID. Then we first point to the element we have found, then its parent node, and then run the function removeChild and tell it which element to remove. Wouldn't it be better to just point to the element and call a function named remove? Here we just add the remove prototype function to the object type element and add a function named remove. The function is the exact same as above, but we use the this keyword to dynamically point to the element we're trying to remove. So this is your new code. Much cleaner. I should probably point out that you shouldn't extend prototypes like this without checking if it already exists and stuff like that, but I just want to point out how easily it actually is. So this is the early beginning of your own library. The remove function could take parameters to trigger a fade out animation before it's removed, and that's when things are really starting to get interesting. Before we move on to function scopes, I have to tell you about how functions can return values and how this fits in with the function calling. Whenever a function is executed, it can return something. To understand what return is, think of it as replace instead. The function call is actually replaced with what the function returns. In this example, we have a simple function that returns a string John. When we call this function here, think of it as we are actually replacing that function call with the object that is returned, in this case the string John. So the return name function call is actually the string John. And since we now have a string object there instead, we can call another function, for example to uppercase. And let us add another just to see again how values are returned and replaced. This time the substring function with parameters that will return the two first letters of the string. And finally, let's see how all these values actually are replaced as we call the prototype functions. This may not be a big surprise to you, but how it is visualized might be. My point is, what you visualize in your head determines your trail of thought. Often it is good to see something you know in a different way to get you off trail, or just plain see it on the board here. It might lead you to new trails of thought and new solutions. Now this got a bit philosophical, so we should probably just move on. So, function scopes. You'll recognize this object type definition from earlier, person. When you create a new object of this type, it will get two properties, a name and an age. But what about the variable declaration here? Where will that be available? To explain function scopes, I want to put an image of it in your head. Think of JavaScript as a computer with a hard drive and memory. The person definition here is stored in the hard drive, and when it is executed, it is moved to the memory. When the function is done executing, it will return a new object to the hard drive and remove the scope from the memory. So the object is still there with all the properties, but the scope is gone. Since variables live inside the scope, they are also gone. So in this case, the variable nameLength is only available when the function is executing. You cannot point to it like you would point to a property. I should also explain here that even though the variable is gone, that doesn't mean it's gone when you execute the function again. So if you execute a function the first time, all the variables will be undefined. But the second time you call the function, the variables are actually still there. But probably you want to change them again, so it doesn't really matter. But it's good to know. So even though the scope dies, all the information isn't gone. And it's the exact same thing when creating a function as a property of an object. In this example, there are two different functions, the setNameLength function and readLength function. The variable inside the setNameLength function here, length, is only available within the function scope. But as soon as we use the this word and point back to the actual object, we can store the length there instead as a new property of the object, now making it available whenever we point to the object. So in this case, if we call the readLength function, it will point to the object's property called nameLength and log that. Now we're starting to see how we can share values between functions inside objects, which is important to write clean code. If we look at the scope as a table, we can see how scope chains work. A scope chain is when you create a new scope inside another one, or in other words, a function inside a function. In this example, you see that we have first created a new variable called company name, which contains a string. We have also declared a variable logCompany, which has a function in it. This function lives inside our test function, thus resulting in a new scope. Inside this new scope, we have declared a new variable called company uppercase. The content of this variable points to the one outside, company name, and runs a toUppercase function on it. So the inner scope, logCompany, points to the outer scope. That is perfectly okay. But what's so special about scopes is that they have access to their outer scopes, but the outer scope does not have access to the inner scopes. To explain with this example, the logCompany function has access to the company name variable above, but the test function does not have access to the company uppercase variable, which lives inside our logCompany function. So the code at the bottom here doesn't work because it references a variable that does not exist in the current or any outer scopes. What you have to be aware of here is the cost of finding values outside of the scope. When the logCompany function uses the company name variable, it takes longer to execute than if the variable lived inside the same scope. Again, think of tables. If you create a new function inside of a function, it creates a new table for it, and jumping back has a cost. In my experience, this is where you slow down your application the most, so you should avoid writing code like this in general. But there are times where you actually want to write it like this, and that's when you want to use closures. Closures are the most difficult concept to explain and understand. As I said earlier, a scope dies after execution, which means that when you execute again, you have to revive it. But there is actually a way you can keep the scope alive even after it was executed. The big question here is, why would you want to do that? As I explained earlier, using the computer's hard drive and memory to give you a practical image of it, a scope only lives when a function executes. What a closure does is keeping the scope alive in the memory. This gives you access to the scope after the function has executed. To explain this in a more practical way, closures makes functions run faster. If you have a complex function that you need to call quite often, you can create a closure that will keep the scope of the function alive. Closures can also create dynamic scopes. Now this is a tough one, but what I mean is that you can have a function that creates new scopes. You can choose freely what those scopes should contain and therefore make them dynamic. Think of it as defining a scope type instead of an object type. Instead of using the new keyword to create a new object, you use a closure to create a new scope. This has to be explained with examples. I would also like to mention that you can use scopes for other stuff as well, making private variables to functions and stuff like that, but we won't go into that in this chapter. The first function here does not use closure. It is just a function that can be called with some text. Inside the scope there is a variable called logText. The variable has a function inside which operates as an inner scope. The function can receive a text which will be logged out. So we do that. We call noClosure with some text. This seems a bit silly, but usually you have a lot more complex functions like this, and the point is that every time noClosure is called, it has to create its own scope and the inner scope before executing the code. That is actually not necessary. If we could keep that inner scope alive somehow, it would actually execute a lot faster. So let's look at the closure version of this. We'll take this slowly. First, notice that the function that is put into the closure variable is executed at once. There are 2 parentheses at the end. That means that this function will only execute once, and it is executed when the variable is declared. It will not execute every time you call closure later on. What happens now is that the function that is executed at once will return a new function, which actually is the function you will be calling later. This new function calls our logText function and sends whatever text we want to log. So our variable actually now looks like this. Now that's kind of weird, because now the actual logText function is gone. But actually it isn't. It is still part of the scope and it is alive, which means that it doesn't have to be set up every time you call the closure function. The closure version of this code runs a lot faster than the other one. I hope this example explains it well enough. Just try it out and you'll see the big difference in how fast the function executes. When it comes to the second use, creating new scopes dynamically, we'll have a look at another example. Here we have created a for loop which puts out 5 containers. We want the onClick event to log out the index of the container, or more exact, the value of x when the container was created. What happens here is that the x value is sent to a new scope called addEvent. The x in the addEvent scope will change over time as the for loop keeps calling the function with new values. But inside the addEvent function, we define a new scope again. This new scope is returned, and with it follows the x with the value when the addEvent was called and executed. So here we keep the x value alive with the closure, not a whole function like the previous example. You would think that you could just add new functions directly to each container's onClick property, but that would result in pointing to the value of x inside the outer scope. Is that a problem? Yes, because x in the outer scope changes every time the loop creates a new container, thus resulting in all the containers logging out 4 in this case. So you have to figure out a way to build a new scope for each container's onClick event. That is what closures are. There are other uses for closures also, but the ones I have explained now are most common. Now, I hope I got this through well enough. If you didn't quite get it, don't worry. Closures are the last aha and the most difficult one. I recommend you to start trying different ways of running functions and have a look at Douglas Crockford's YouTube clips. There you will learn more about patterns and the use of closures.